All right, this is the first video for Chapter 5 for Calculus. This is it's going to be, we're going to go over Section 5.1, Antiderivatives. But before we begin, I just want to give a bit of an introduction to Chapter 5 on the whole. So far in this class, we have studied two major topics. We've studied limits and we've studied derivatives. So limits are sort of a theoretical background idea that we need to establish the idea of a derivative, an instantaneous rate of change. But back at the very beginning of the semester, we also talked about another big idea in calculus, which is area under a curve. So you may remember this notion of here's a curve, and then we're going to try to find the area between that curve or under the curve, or really between it and the x-axis. And we discussed a way of doing that involved adding up a bunch of rectangles. Chapter 5 is going to bring us back to this idea of finding area under a curve. And we're going to do the thing with adding up rectangles again, but then we're going to take that idea, combine it with limits, and really take that further so that we can establish a big topic in calculus, which is integrals or integration. So that is one of two big things that we're going to discuss near the beginning of this chapter. The other one is antiderivatives. And when we introduce these two ideas, an antiderivative basically is just the opposite of a derivative. Okay? When we introduce that and the area under a curve, these two concepts will seem completely unrelated to each other. On the surface, they are. They don't really relate to each other initially. But pretty soon, I think next week, we're going to get to something called the fundamental theorem of calculus, which unifies these two seemingly unrelated ideas into one thing, and it really connects the idea of derivative to the idea of area, and the idea of antiderivative kind of is the go-between. So a lot of weird ideas that seem unrelated are going to get tied together next week by this thing called the fundamental theorem. So just wanted to let you know where we're going with this. We're going to start by learning about antiderivatives. So let's start with a definition. An antiderivative of a function f is a function capital F. Okay, notice the original function's being called lowercase f, and the antiderivative is being called capital F. And it's a function for which capital F prime equals lowercase f. So this is literally just the opposite of a derivative. Okay, you take a function, its derivative is its instantaneous rate of change. The antiderivative is a function going backwards, where it's a function whose derivative equaled the one you started with. Let's do a quick example. Let's take the function, let's start this way. Let's look at capital F of x equals x squared. Well, the derivative of capital F would be 2x. So that means that x squared is an antiderivative of 2x. Okay? Your lowercase f in this scenario is 2x. So here we'd have lowercase f of x equals 2x. Okay, so with this capital F, x squared, it's an antiderivative for 2x. Okay, if you start with the function 2x, you can go backwards and say, well, all right, so if we have 2x, what's an antiderivative for that? It would be x squared. Take though the second example. Let's call that number 1. Let's look at number 2 here. Capital F of x equals x squared plus 5. Well, what's the derivative of that? Capital F prime is equal to 2x. So, again, this is an antiderivative for 2x. Okay, so what we're seeing here is two different functions. I gave them the same name, okay, but they were meant to be two separate different functions that are both antiderivatives for the same starting function. Lowercase f of x equals 2x. Okay, so if you ask the question what is the antiderivative of lowercase f of x equals 2x? If you ask that question, it doesn't really have a good answer because the antiderivative is the wrong way to ask it. An antiderivative is really the best we can do. Okay, because there's in fact infinitely many different functions that could be antiderivatives for any given function, and the way you can like prove that is to notice that the fact that I added 5 to this function here was completely irrelevant. Like it could have been any other number that I added, right? When you take a derivative of x squared plus a constant of any kind, you're always going to get 2x because the derivative of the constant term is 0, and adding 0 doesn't do anything. So when we ask what is the antiderivative, that doesn't really make sense because there's not just one. This is something that makes it very different from derivatives. The derivative of a function is unique. There's only one of them. But an antiderivative is not a unique thing. There can be more than one different function that serve as an antiderivative. So we're going to explore that idea a little more in the next video.